Hello and welcome to our YouTube channel Rubel Solutions. In this video, I am going to discuss about underwater wireless sensor networks architectures. There are different architectures so far in the field of underwater wireless sensor networks. In this section, we discuss the common UWSN architecture. The data credit for this video is the internet source and reference below as A. First of all, first architecture was 1D UWSN architecture, that is one-dimensional. UWSN architecture refers to a network where the sensor nodes are deployed autonomously. Each sensor node is a standalone network itself, responsible for sensing, processing, and transmitting the information to the remote station. A node in this type of architecture can be floating buoys, which can sense underwater properties, or it can deploy underwater for a particular period of time to sense information and then floats towards the surface to transmit the sense information to the remote station. It can be autonomous underwater vehicle which dives into the water, sense or collect the underwater properties and relay the information to the remote station. In 1D UWSNs, the node can communicate using acoustic, radio frequency or optical communication. Moreover, the topological nature of 1D UWSN is a star, where the transmission across the sensor node and the remote station is carried over a single hop. Now the second architecture is 2D UWSN architecture. Two-dimensional architecture. UWSN architecture refers to a network where a group of sensor nodes, that is cluster, are deployed underwater. Each cluster has a cluster head, also called anchor node. The clusters are fixed as they are anchored at the underwater surface. Each member of cluster gathers the underwater data and communicates it to the anchor node. The anchor node gathers the information data from all its member nodes and relay it to surface buoyant nodes. In 2D UWSN, the communication is carried in two-dimensional, that is, each member of cluster communicate with its anchor node with horizontal communication link, while second, the anchor node communicates with the surface buoyant node with vertical communication link. In 2D UWSN, acoustic, optical and RF communication can be used depending on the type of application and the nature of underwater environment. In 2D UWSN, acoustic communication is preferred for underwater anchor node and the surface buoyant node due to type high distance between them. For the cluster of nodes, the network arrangement can be star, mesh or ring depending on the application requirements. The 2D UWSN can be used for both time critical and delay tolerant applications. Now the third one is 3D UWSN architecture. In this type of network, the sensors are deployed underwater in the form of clusters and are anchored at different depths. Due to deployment of sensors at various variable depths, the communication between the sensor goes beyond the two dimensions. There are three communication scenarios in this architecture. First is inter-cluster communication of nodes at the different depths. Second is intra-cluster sensor anchor nodes communication. And third is anchor buoyant node communication. In all three types of communication scenario, acoustic, optical and RF links can be used. Now the fourth type of architecture is 4D UWSN architecture. Four-dimensional. 4D UWSN is designed by combination of fixed UWSN, that is 3D UWSN, and the mobile UWSN. The mobile UWSN consists of remotely operative underwater vehicles, ROVs, to collect data from the anchor nodes and relay the data to remove station. ROVs can be autonomous, submersible robots, vehicles, ships, and even submarines. Each underwater sensor node can be autonomous in relaying the data directly to the ROVs depending on how close that particular sensor node is to ROV. The communication scenario between the ROV and the underwater sensor nodes depend on the distance and the data between them, and either acoustic or radio can be used. As the transmission is to be directly relayed to ROV, the sensor which have the large data are close to the ROVs can use radio links, while the sensor which have small data to transmit or are far from the ROVs can use acoustic links. I hope this article is beneficial for some of you, and I was reading this topic and wanted to discuss with some of you, or if many of you like it, please comment if something is wrong, if something is right, if you like it, if you unlike it. Please do tell me, as your feedback is important and I can improve myself by seeing your feedback. Thank you so much. Love.